Okay, this is just a quick video about graphing one cosine function, but it's going to be the same for sine. You're just going to work off of a different parent function. These are a little bit harder. They are going to include amplitude and period, and we're just going to go through one example. This should help you with your homework a little bit and think about this on your own a little bit. Okay, let's graph y equals 1/2 times the cosine of 3 theta. We learned that these are in the form of y equals a times cosine of b times theta. And we're going to use that. I'm going to erase this, but you should write this down on your paper so that you have something to reference back to. That first letter is a, and in this case, a is 1/2. And our amplitude is 1/2, which is the absolute value of a. So if a was negative 1/2, it would still be an amplitude of 1/2. This 3 is what we're going to use to find the period. And the period is the equation 2 pi over the absolute value of b. In this case, b is 3, so we're just going to have 2 pi over 3. If we had a negative 3 there, we would still use positive 3, and our period would still be 2 pi over 3. Let's look at this for a second, though, and look at it compared to our parent graph of cosine of theta. This is our parent graph of cosine of theta, and if we look at this graph, the period of cosine of theta, the time it takes to get all the way back to this location over here is 2 pi. So we have a period of 2 pi over 3 now. So what do we have to do to 2 pi to get to 2 pi over 3? We have to either multiply by 1/3 or we have to divide by 3. So we're going to use that information to help us graph our new function. Okay, so we said that our period is multiplied by 1/3 or divided by 3. So when we do our period for our new function, we're going to have to multiply by 3 because 2 pi times 1/3, which is the same thing as 2 pi over 1, equals 2 pi over 3. So when you do these, you really have to think about what you have to multiply by to get our new period. Okay, let's figure out what our points are first for just y equals the cosine of theta. If you look at your parent graph, I don't have mine pulled up right now, but you should have the parent graph of cosine of theta. Our first point is 0 radians, and it lands at 1 on the y-axis. Our second point is pi over 2 radians, and it lands at 0. Our third point is pi negative 1. Our fourth point is 3 pi over 2, 0. And our last point is 2 pi, 1. Now look at your amplitude. We're going to do, the next part of our table is going to be accounting for that amplitude. So we're going to fill in this table for y equals 1/2 cosine of theta. And what this means is our amplitude is 1/2, and our amplitude affects how high or how low our graph goes. It affects our maximum and our minimum. Our maximum and our minimum is related to y. So with this, we are going to multiply y by 1/2 because 1/2 is our amplitude. So let's go ahead and do that. We're going to multiply all of our y's by 1/2. So we're still going to have 0. We're still going to have pi over 2. We're still going to have pi. We will still have 3 pi over 2. And we will still have 2 pi. However, 1 times 1/2 is 1/2. 0 times 1/2 is 0. Negative 1 times 1/2 is negative 1/2. And 0 times 1/2 is still 0. 1 times 1/2 is 1/2. So we've accounted in for our amplitude on all of these now. Now we need to add in our period. So this is going to be the final graph. This is going to be our final functions for this graph. So we're going to have y equals 1/2 times the cosine of 3 theta. Now we said right here that we have to multiply by, oops, I wrote this wrong, by 1/3, because 1/3 times 2 pi is 2 pi over 3. So we are going to multiply our x's. So multiply x by 1/3. We already dealt with our y's, which is our amplitude. Now we're dealing with our period, which stretches it horizontally. So 0 times 1/3 is still going to be 0, and then we still have 1/2. Now go ahead and do pi over 2 times 1/3, and we're going to get pi over 6. So we have pi over 6, and we still have 0. Now we need to do pi times 1/3. So we're going to have pi over 3. So we'll have pi over 3, and we still have negative 1/2. Then we are going to do 3 pi over 2 times 1/3. That's going to give us 3 pi over 6, which we can simplify that to be pi over 2. So we're going to have pi over 2, 0. Next we're going to do 2 pi times 1/3, and we get 2 pi over 3. So our last one is 2 pi over 3, and we still have 1/2. These are going to be our final points that we are going to graph. So I'm going to put our points on the next slide and put a blank graph there, and we're going to graph these points. Okay, here's our points and our graph that we're going to fill in. We're going to have to use the unit circle for this because our graph only has pi over 2, pi, 3 pi over 2, and 2 pi. And some of the points that we have, like pi over 6, pi over 3, and 2 pi over 3, are not included on there. So we're going to have to use our unit circle to label these. So let's label this first one, this halfway mark between 0 and pi over 2. If we look on our unit circle, pi over 4 is between 0 and pi over 2. So that line between pi over 2 and 0, that's just going to be pi over 4. If you look at the next one that we need, which is going to be the point between pi over 2 and pi, the number that lies between those two is 3 pi over 4. So let's go ahead and label that line 3 pi over 4. Now the next one that we need is that midway point between pi and 3 pi over 2. If we look at it on our unit circle, 3 pi over 2 and pi, the one that lies between that is 5 pi over 4. So let's go ahead and label that. And the last one that lies in the center of 2 pi and 3 pi over 2 is 7 pi over 4. So go ahead and label that. This is going to help us determine where our points need to go. So let's graph the first one, which is 0, 1/2. That one's done. Next we need pi over 6, 0. And if we go back and we look at our unit circle, pi over 6 is between pi over 4 and 0. So we need to go between pi over 4 and 0, and we're going to graph that at 0. So that one is done. Now we need pi over 3, and let's look at our unit circle again. Pi over 3 is between pi over 4 and pi over 2. So right between pi over 2 and pi over 4 on our graph, we're going to graph negative 1/2. That one is done. Now we have pi over 2, 0. That one's easy. We already have that one labeled. And we have 2 pi over 3, comma 1/2. If we go back and look at our unit circle again, 2 pi over 3 is between pi over 2 and 3 pi over 4. So go to pi over 2 and 3 pi over 4, and we're going to graph that point at 1/2. Now, obviously, these aren't exact, but they're pretty close. And this is going to continue and look exactly the same on the other side. So this one's going to be halfway between at 0. This one's going to be about here. The next one's going to be at pi over 2, negative pi over 2, 0. And the next one's going to be about here. Now, we're not going to graph the rest of this very exact, but go ahead and connect those points and then just kind of roughly graph the rest of your function. We're not going to graph the rest of these points because we won't need them, but in the future you would know how to graph these points. You would just keep continuing. So this is how you would graph your functions. Look at the parent graph, use your unit circle, and do it one step at a time. Start with just the amplitude, and then do your period. The period, the key is you have to think about what your original period is multiplied by. So for period, what you should ask yourself is, what is 2 pi multiplied by? That's really the key to this, and that's honestly the hardest part. And fraction work, you have to work on your fractions for this. If you guys have questions, feel free to email me or ask me questions in class, and I'll be willing to help you.